Hello, my name is Steve Rowley. I'm the Science and Operations Officer at the National Weather Service in Charleston, South Carolina. And what I'd like to do today is just give you a little insight to some of the challenges that we face during severe weather operations. And I want to use a recent severe weather case as an illustration. And what I have here on the screen is this is the base reflectivity. This basically is the Doppler radar giving us an indication of the intensity of the rainfall that's occurring. So where you see the yellows and the reds, there's heavier rain that's occurring. And indeed, there's just some thunderstorms that are approaching the Savannah, Georgia area. Savannah, Georgia, located right about here. So this band of thunderstorms is what I want to call your attention to. And when I toggle to the other image, one of the interesting things about the Doppler radar is we can actually see the winds inside of the thunderstorms. In general, the greens and blues are moving toward the radar, and the reds are moving away from the radar. So we actually have some very strong winds that are occurring about 4,000 or 5,000 feet above the surface. I actually have some winds that exceed 70 miles per hour in some of these pockets. And these thunderstorms are moving off toward the northeast. Ordinarily in this type of situation, we would have severe thunderstorm warnings in effect for these types of winds. However, what happened was these thunderstorms actually crossed the Altamaha River as they moved toward the north along the I-95 corridor, and we were not getting very strong wind gusts. In fact, most of the wind gusts were less than 30 miles per hour, despite the fact that just a few thousand feet off the ground, the winds were exceeding 60, 70 miles per hour. So it was an interesting situation, and once we got a handle on what was going on, we realized that the environment was simply not going to support these strong winds getting down to the surface and producing damage. So we didn't issue any severe thunderstorm warnings, and indeed we had no reports of damage. Now when we go later on in our radar sequence, we've moved north now along the same line of thunderstorms, and we're in Charleston County, South Carolina. And what I want to call your attention to here in the reflectivity is it looks like an S pattern. And indeed, there's a small low pressure system that has developed along this line of thunderstorms. I'm going to go forward just a few loops, a few frames here. Okay, and you can see that low pressure system. Now, what you need to remember about low pressure systems is that the circulation is counterclockwise. So the winds are turning in this direction. And we're going to see in a moment, we're going to see now winds that are moving away from the radar. These winds here, and again, we've got wind gusts, winds within 2,000 feet of the surface now that are exceeding 60 miles per hour. The difference between this and what was occurring down in the Savannah area is these winds are beginning to reach the surface, and indeed, you can see those outbounds, the reds moving away from the radar, in some cases exceeding 60, 70 miles per hour. And we were getting wind damage reports from Charleston County and eventually into Dorchester County. You can see how those winds actually strengthen. And if I go back, you can still see that little low pressure system that's tracked off toward the northeast. So what was the difference between this environment that didn't produce damaging winds near Savannah and this one that was producing damaging winds over Charleston County? Well, I think the first factor is if I back right up, see that little low pressure system. There was no low pressure system with those thunderstorms down to the south, but a low pressure system had developed up in this area. And those counterclockwise winds, I think, helped tap into some of the stronger winds off the surface and brought those down to the surface and produced wind damage in a more efficient manner. The second thing that probably contributed greatly to this is the water vapor, is the moisture. Okay, this is the water vapor image. This is the new GOES 16 satellite. We were actually getting images every minute during this event, and I'm going to go forward here just a little bit, and we can see where there's moisture out here, where there's white, and then where these darker reds and oranges are is where the dry air is. What we're concerned about with thunderstorms, with the proximity of dry air, is sometimes when dry air gets in close to thunderstorms, it actually increases the chance that you're going to get damaging wind gusts within given thunderstorms. And here, as these thunderstorms were moving through the Savannah area, some of these colder cloud tops right in here, that dry air was still back toward the west and southwest. Now, if I go forward a little bit here, I'm going to have to back up just a little bit for you. In fact, we'll just go through the whole loop for you here. So follow the dry air, follow those orange, that orange and darker red colors, following the thunderstorms. And it was right about this time in Colleton County, right in here, that dry air seemed to catch up with the thunderstorms. And that's when we started to get the actual damaging wind gusts at the surface. Earlier, the dry air was back here to the south and southwest. Then it caught up to the thunderstorms. So I think the low pressure system that developed along the line of thunderstorms and the introduction of this dry air, again, this is looking higher up in the atmosphere. This is not right at the surface. This is actually higher up in the atmosphere. I think that enhanced the potential for damaging wind gusts. And indeed, we did have some wind damage in this area where we had none down here to the south. So a challenging situation, just a little insight on some of the challenges that we face. The atmosphere will change over a relatively short period of time, and this is something that we need to keep up with as meteorologists and radar operators. Thanks for watching.